5. It's the start of a new week and more importantly our last week of remote learning. Yay! You'll all hopefully be back in the classroom with us next week, which we are all looking forward to seeing you. And for a new week we have another bit of new learning to do with our fractions in maths today. So the learning question is, can I multiply non-unit fractions by an integer? Now you might say that sounds awfully familiar to what we learned on Thursday last week. But the difference is you would be multiplying by unit fractions on Thursday. What's a unit fraction again? That's right, unit fractions have a 1 as the numerator. Non-unit fractions can have numbers more bigger than 1 as the numerator. So that's what we're going to look at today. To start you off, I've got 4 warm-up or starter questions for you to have a go at. So pause the video and see if you can answer the questions on the board. So you should have had a go, and our first one, we've got 4 multiplied by 1/9. And you should all know from Thursday that when we're multiplying fractions by a whole number, what we're actually just doing is multiplying the numerator. So what we're doing here is 4 times 1, or we've got 4 lots of 1/9. And I know that that's going to be 4 ninths. If we've got a ninth, add a ninth, add a ninth, add a ninth, I've got 4 ninths altogether. So 4 ninths for that first one. And then we've got, which of the following statements is correct? And we've got 1/5 multiplied by 4 is 4/20. Or 1/5 multiplied by 4 is 4/5. Which one did you think was correct? And you should all be seeing that if we've got 4 lots of a fifth, we're going to have 4/5. So that is the correct one. A bit of a bonus question for you. What have they done here? Could you explain what they've done here? And you should be able to see that actually they've multiplied the numerator and the denominator of our fraction, because 1 times 4 is 4 and 5 times 4 is 20. So they got a little bit confused and thought you had to multiply both numbers, when we know that you don't, because you're adding the same fraction, the same share. It's just lots of it, more than one lot of it. Okay, so 1/5 times 4 is indeed 4/5. And this one, this might have thrown you a little bit, simply because the answer is at the front, or is at the start of the number sentence. But what it's really asking you is 11 times a sixth. So 11 lots of 1/6. So we're doing 1/6, add 1/6, and 1/6, all the way until we've got 11 lots of it. And we know by doing that, that all we're actually doing is multiplying the numerator and the integer. So it will be 11/6. Oh, 11/6. What type of fraction is 11/6? It's an improper fraction. So when we see improper fractions like that, the question might ask for you to convert it, but it's always good to give your answer as a mixed number. So what would 11/6 be as a mixed number? And you're right, I can get, and you're right, I can get one whole group of 6. Let's change colour. I can get one whole group of 6 with how many left over? 7, 8, 9, 10, 11. 5/6. Because the denominator doesn't change in our fraction. 1 and 5/6, or 11/6 like we came up with first time round. And our last warm-up question, how many 13ths multiplied by 3 would be 3/13? So we've got 3 lots of 13ths. So if we've got 3/13, or multiplying it by 3, we must have started with 1/13, mustn't we? So 1/13 times 3, yep, because we know we would have to do 1 times 3, which would be 3. So we can check our answer using sort of the inverse or solving the problem to check our workings. Well done if you got all of those right. Moving on to today's learning, which was multiplying by non-unit fractions. The only thing that is changing is that our fractions will have a number greater than 1 as their numerator. The method stays the same. And we've got the question here of 2/9 multiplied by 3. And just like on Thursday, when I said multiplying, we can think of it as lots of, or repeated addition. What we're really doing here is we're doing 2/9, add 2/9, add 2/9. And we know when we're adding fractions with the same denominator, we can almost ignore the denominator and just add the numerators. So what we're really doing is 2, add 2, add 2, which we know is 6, and our denominator, stays the same. So our answer is 6/9, like that. Exactly the same method. We can use repeated addition, or just simply know that we're doing 2 times 3, which would give us the 6. Okay, and now we've got 2/7 multiplied by 3. So again, let's use a bar model this time to help show what we're doing. So what you've got to imagine is I draw my bar model, but I'm going to split it into 2 because it's not 1/7 or 1 of something like we were doing last week. Now we've got 2/7. So this whole piece here, this bar, is equivalent to 2/7, like that. And how many lots of those have we got? We've got 3 lots of those. So I need to do, so I need to have another group of 2/7, halving it because there's 2 of the same, 2. And then that's another lot, but we needed to have 3 lots in total. So I'm going to do another one. And now what we've got is 2/7, 2/7 there, 2/7 there, and we can go 1, 2, 3, 4, 5, 6. Again, 6/7 is what we've got. 6/7, okay? Or we can think about it as all we're doing is multiplying our numerator by the integer to give us 2 times 3, which is 6. Okay? Nice and easy, but I just thought I'd show you with the bar model again to show what we're doing. We're repeating the same share. It's still 2/7, that's why the denominator stays the same. You're just having lots of or groups of it. So we can use a number line to help us with this question because repeated addition is just counting up using our fraction. But this time we're counting up in 2/7 instead of 1 or whatever. So got a number line here, and we can imagine that each little line is a 7th. So if we're adding on 2/7 each time, we need to jump 2 spaces, 1, 2. So we've added 2/7 there. 0 add 2/7 is going to be 2/7, isn't it? What's going to come next? 2/7 add on another 2/7. What's that going to be? And it is 4/7. Counting up in our 2 times tables. And then add another 2/7 because we know we've got to do 4 lots of because of our integer. Add another 2/7, 4/7, 5/7, 6/7. And one more lot of 2/7. 6/7. Oh, add one more 7th. What do we get? 6/7. Add 1/7. 7/7, or 1 whole. Add another one would be 8/7, like that. And we've got 1, 2, 3, 4 lots of 2/7, which gives us the answer of 8/7. How else could we write 8/7? Noticing that that is an improper fraction because the numerator is bigger than the denominator. What's that going to be as a mixed number? That's right, we know that when we added 1 more 7th onto our 6/7, we got to 1 whole. So what we've got as a mixed number is 1 whole and 1/7, like that. Okay? Last question. Ooh, it's a bit of a missing number one. And it's asking you how many 9ths multiplied by something is 4 wholes. 4 wholes. Oh, I've got to do a lot of working out for this one. But first things first, we've done questions like this before. We need to first work out how many 9ths are in 4 wholes, okay? So we've got to think, how many 9ths are in 1 whole? That's right, 9 or 9/9. So what we're doing, we need to do 9 times 4, don't we? Because we've got 4 wholes. 9 times tables or our 4 times tables, because it's commutative, it works both ways. 9 times 4, oh, that's 36. So our answer, what we're working towards, is actually 36 ninths. 36 ninths is equivalent to 4 wholes. And this is asking us how many ninths, but we've got this little clue down here, and it says we're looking for a non-unit fraction. What does that mean we can't have in this box here if it's a non-unit fraction? That's right, it can't be a 1 because 1 as a numerator is a unit fraction. We're looking for a non-unit fraction for this answer. So 36 ninths. So if we were looking to do, so if we were looking for a unit fraction, we could do 1 times 36 to get 36 ninths, couldn't we? What if we're doing 2 ninths? How many lots of 2 ninths would go into 36? And what we can do for that, we can think 36 divided by 2. What's half of 36? And we need to think, I'm going to partition this. I'm going to do 6 divided by 2, which is 3. 30 divided by 2, which is 15. And I just need to make sure I'm going to do 6 divided by 2, which is 3. And then I'm going to do 30 divided by 2. I'm going to partition this, which is 15. And then what we need to do is 15 add 3. 16, 17, 18. So we could do 2 ninths multiplied by 18. And that would give us the same answer as 36 ninths. See if you can find another solution to this question, because non-unit fraction can be any number that's greater than 1. Is there another way to solve this problem? Maybe leave a comment on the blog if you find another solution to this problem, okay? Your worksheet today is lots of practice with multiplying non-unit fractions by integers. Exactly the same method as we were doing last week. The only difference is you've got numbers greater than 1 as the numerator that you're multiplying by. Best of luck. See you tomorrow.